This video can serve as a lesson for an algebra class on functions, so please pause the video where necessary before solutions are presented. Do now. What do you see? What do you wonder about this picture? One of the most important things in problem solving is being able to construct the problem statement itself. Problem. Notre Dame has the football with 2 minutes and 33 seconds left on the clock in the fourth quarter. It is 1st and 10. You have 40 seconds to snap the ball on each down. Does Notre Dame have a winning strategy? This problem statement was constructed by looking at the little details in the picture. And also, if you do not know some of the details of football, you can always research it up. Don't be lazy. So yes, there is a solution to this. They can take a knee on each of the downs and win by running out the clock. This is because there are 4 downs in American football. You have 40 seconds, plus 40 seconds, plus 40 seconds, plus 40 seconds, which equals 2 minutes and 40 seconds. Even taking into account they can't snap the ball at exactly 40 seconds, they still have enough time. Let's also look at a little geometric schematic. Who is this guy in the picture? This is Kareem Abdul-Jabbar. What is he famous for? Well, he played on the Lakers in the 80s and 90s. He was the NBA all-time leading scorer with 38,387 points, and he won a record 6 MVP points. One thing you may not know is that he was coached by John Wooden in college at UCLA, and John Wooden is famous for his many maxims. One very important maxim he has is, do not let what you cannot do interfere with what you can do, and never mistake activity for achievement. These are very important proverbs. This lesson is an introduction to mathematical functions. What is the most basic function that you can have? Well, you can have a constant function. Here Mario is trying to duck out of the way of Bullet Bob. You see the straight line, the straight horizontal line, is what a constant function would look like. For example, f of x equals 1. The next step up from a constant function is what we would call a linear function, although actually geometrically they're the same. A constant function is just a linear function with a slope of 0. And here Mario is swimming at an angle to try and avoid the fish and get the coin. This could be modeled by the function f of x equals 2x plus 1. And you see algebraically, there is no exponent by the x variable. That implies it's just 1. This is how we know it's linear. Here Mario is trying to hit the question mark box as he hits the Goomba. What is the path of his trajectory as he jumps? He's trying to get a mushroom. This is known as a parabola, and this is the next step up called a quadratic function, which can be modeled by f of x equals negative x squared. A more complicated function would be a cubic function, which is the path of this ghost here. Here are some examples of different functions in a single variable. F of x equals 2, which is just a straight horizontal line at y equals 2. It's constant. Then we have a linear function, f of x equals 2x plus 1, which is linear. Then we have a cubic function. We have 4th degree functions. We also have functions of 2 variables, which are useful in geometry. For example, we have translation in geometry, which is described by a 2-variable function. We also have surfaces in geometry, which are 2-dimensional, which are described by 2 variables. So this is a paraboloid. And there are many different representations of functions. For example, we can have a table. We can have an algebraic formula, or a rule, in the form of f of x equals some formula. We can have a graph. We can have an arrow diagram. We can have ordered pairs in a set. Go to Desmos.com and plot all the 7 points previously here, and make sure they go through all the same line. There's also a connection to modern mathematics. Let's utilize this idea of functions in a problem. Paula had been on a diet for 3 months and currently weighs 151 pounds. After 5 months of dieting, she is at 147 pounds. If her weight loss follows a linear progression, which it doesn't, but for the sake of simplicity, we'll just do that here, find how much weight she has lost after 8 months. Solution. We view these as data points, TW, on the time-weight axes. So we have 2 points, 3, 151, and 5, 147. The question is, what is the y-coordinate of 8, comma something? Well, let's calculate the slope. Let's try to construct a function that'll tell us the weight as a function of time. So m, the slope, equals the change in y over the change in x. In this case, the x-axis is actually the time axis. So we get the slope is -2. So in an application, it's always very important to say what the problem means. So for example, what does the slope mean? What are the units of the slope? We have the slope is -2, but what are the units? Well, the numerator is weight, and the denominator is time. This means she loses 2 pounds per month. So the units are pounds per month, and the negative means she loses 2 pounds per month. And that means we can find our function. So b equals 157. So the function that models her weight loss as a function of time is f of x equals -2x plus 157. So now we just plug in 8, find in what f of 8 is. That equals 141 pounds. Here's another problem. If f of x equals 3x plus 2, find f of 0, f of 1, and f of 1/3. It's pretty simple. You just plug in the number 0 wherever you see an x and compute. Similarly, for part B, wherever you see an x, you just plug in the number 1 and then do the calculation. And again, for C, you just plug in 1/3 into f of x wherever you see an x variable and do the calculation. If you enjoyed this presentation or found it useful for teaching, please check out my YouTube channel and my book.
Limu Limo at your service. Here to help you save hundreds by customizing your car insurance.
If you are learning from the free resources from this channel, then you'll love my book, Learning Isn't Linear, available on Amazon.com. It contains crisp illustrations to accompany non-standard problems with extremely detailed solutions. The link is in the description. If you get the ebook version using the Kindle, there are clickable links throughout the book to Desmos and GeoGebra projects. It is very easy to search within the book for specific topics. As you can see, chapters range from algebra to calculus. Whether you are a self-motivated student solving problems on your own, or a teacher preparing for a math class, this book is a valuable resource to add to your repertoire. Okay, till next time, and remember, prioritize long-term learning over short-term test taking.